第一部分，乘客出行全站式数字自助服务，以乘客为中心，掌上地铁作为线上服务统一入口，集成线下数字服务，场景化点对点给客户一体化贴心服务。出行前，乘客可获取线网实时拥挤度、末班车可达、进站排队时间等信息，合理规划路径。未来，数据价值深挖将衍生出更多应用可能。进站乘车中，小包乘客展示绿码，快速通行安检。车站车厢温度、灯光可根据拥挤度自动智能调节。乘客可在交互屏、投屏、手机上获取站立导航、设备设施可用、客流管控、列车运行、车厢拥挤度、强冷车厢分布、到站提醒等信息，体验到提前预知、心中有数、自主选择的精准服务。智慧客服对标无人值守场景，增设一体化服务中心。自助票务机可实现22项高频业务乘客自主办理，期间任何疑问可一键联系远程客服协助，客服机器人提供主动迎宾、语音问询、智能导航等拟人化服务。同时，示范站还实现了语音购票、刷脸无感过闸、智能边门、自助失物领取和雨伞租借等功能。乘客自助可替代81%的人工服务，原固定值守客服人员可机动兼顾设备操作引导、站厅站台巡视等多种业务。出站时可开具区块链发票，获取出入口导向、公交和机场接驳指引。第二部分，车站管理全景自动运作。车站管理以数字平台为管控核心，支持车站全天的高效安全自动运作。运营前自动诊断确认设备设施状态，实现一键运营，设备安全联控，一键式可启动出入口卷帘、扶梯、环控通风、照明等设备的开关站流程。运营中，针对扶梯异常、站台门加人加物、晚点客流管控、列车故障等事件，可场景化自动触发预案联动，实现警示提醒、信息推送、设备响应、人员组织、指挥调度，一体化快速安全处置。建立驾驶疲劳检测和站台作业分析系统，可实时辅助员工标准化作业，保障乘客出行安全。建立环控能源管理系统，实现车站能效管控可视、可诊、可优，节能率达15%。运营后，智能管控夜间施工作业，实时监控隧道人车状态，检测安全冲突、非法入侵自动报警，智能激活风险管控措施，保障夜间轨行区作业安全。视频感知自动巡检分析，24小时智能识别23类设备运行异常、乘客异常行为，并自动弹窗报警，触发联动响应。第三部分，车站设备智慧运维。智慧运维围绕智慧检测、健康管理、智慧检修三大方向，实现提质、控源、降本。研发机电巡检 BFC 智慧运维系统，实现全流程电子化检修，智能辅助人工作业，研发红外热成像、远程抄表系统，实现智能监测、自动判别异常，替代人工巡检。研发机电设备健康管理系统，建立算法模型，实现环控风机、水泵、电扶梯等设备健康管理评估、寿命趋势预测，逐步以状态修替代计划检修，提高维修的精准性和经济性。深铁运营将持续推进数字化转型升级，打造智慧城市重要窗口标杆，为深圳成为世界级城市枢纽、先行示范区、国际一流湾区助力。
我觉得
This is a 5-minute video. I think it explains a lot better than I could say in 5 minutes. I just want to share two things with you. First, I'd like to introduce to you about Shenzhen Metro in general. Shenzhen Metro was founded in 1998 in July. In 2004, we launched the first line. Now we have the 3-in-1 structure with national, intercity, and urban railways, and also the 4-in-1 system with construction operations, station and city development with resource operations. And we have the metro businesses serving the city as our development ideas. Total asset is over 400 billion Chinese yuan, profit in 2019 over 11 billion Chinese yuan, maximum daily passenger throughput 6.35 million person times, and the ride-sharing rate with buses is 47%. Now the situation has recovered after the pandemic. It was 51% in the past 3 months. Back in 2019, we worked with McKinsey for our 10-year strategic planning. The core of this planning is that, on one hand, we will go through digital transformation, and secondly, we will have the station and city integrated development. After this project with McKinsey in 2019, the whole Shenzhen Metro Group started to work with Huawei and other well-known companies in the industry for our digital transformation. We have joint labs with Huawei, and we have other joint projects. The main purpose here is to cultivate employees, drive transformation, improve service quality, create benefits, and eventually serve the city so that we can build our core competitiveness. When it comes to operations for digital transformation, both our leaders, McKinsey and as well as Huawei, believes that operation is the key to successful digital transformation. In other words, it's the main battlefield. At the beginning of 2019, we built this 5171 smart system architecture. Last year, we've been talking about this in different events. So we have the unified storage, analysis, transmission, locations, and standards. In H1 2019, we had 25 construction standards for Shenzhen Metro. So that's a high-level design. ERP system is used for asset and production management. So production and operation are managed by ERP. Now we think that we need to expand a bit because a single ERP system may not be sufficient in terms of its capacity. 7 refers to the 7 functional modules, and lastly 1 is one unified system. We have 3 levels of management and decision making. In our digital transformation journey, we started to drive it through innovation from 2016 and 17. During that 2 years, several metro groups started to do that. There are 5 aspects here: all domain participation. We are not leaving out any domain. All system integration. And thirdly, all data convergence. All data are streamlined on the cloud. Number 4, all scenario planning. And lastly, industry-wide promotion. Last year, at different events, I also mentioned working on smart metro is about the industry, is about the ecosystem. Solely depending on Shenzhen Metro would not be sufficient.
So we hope that with the help of a Huawei corporation, we can work with each other so that the smart metro project will be finally pulled off. Second part of my presentation, I'm going to walk you through the intelligent station because we already looked at those application scenarios. To be frank, the railway station or metro station, this is either the simplest or most complex scenario for metro service. It is very comprehensive. It usually has the biggest impact on passengers, the metro station, because as a passenger, because he or she is either on a train car or staying at the railway station, right? Because it is the service that the passengers enjoy that matters a lot. How can we operate the intelligent train station? So we thought about this topic. Then our solution is scenario driven, because the scenario of the operation of the station is divided into 3 business flows, namely passenger service and operational management of the station per se. Third, the operational and the maintenance management of the gear and equipment at the station. And we discovered that a business flow, there is like some distinguished characteristics. First, there is many labor-based services with high labor cost. All those service items we have, basically, they're like kind of a people-on-people type of a service, like an ocean of a people, so that passengers either have a touch point with our assistants or staff or those security guards. Second, we rely heavily on manual labor for, let's say, kind of inspection within the station. And we have one metro station with over 30 exits. So the switch station, it is really labor intensive. We have to have several groups of people operating. And due to security reason, we have to have one run for inspection every 15 minutes, right? We have to send over a lot of people for inspection around. Third, O&M. And we have low efficiency in terms of human-machine coordination. Second, we react to the customer requirements in a reactive manner with a low service level. Third, the backward type of O&M, like the predictive kind of a maintenance. This is an area where we're lagging behind. Those are business pain points we've identified. Then we begin to make some plan trying to tackle the pain points. For example, the user requirement-driven scenarios. And leveraging the opportunity of intelligent station, we engage all those stakeholders, the service and repair team and a disciplined people come on board as well. And we work with over 30 contractors or even more. So altogether, we pool our resources around and work with one another, trying to develop the smart station. Then the broadband and the wireless network, those infrastructure, altogether 36 applications. So service, O&M, operation, command, and construction, energy management, altogether 7 scenarios and applications. So we managed to upgrade the service, management, and O&M. In terms of the technological architecture, the very theme today is the ICT technical structure. Mr. Jing is going to walk through more details on this regard. For this very architecture, it is not only true for intelligent metro station, but also it is true for digital metro. The core of this structure is cloud. The cloud is able to congregate all those data. So on a testing cloud, not only that we're able to pull those data related to the station, but the data on other domains are concentrated here as well. In terms of a transmission, those new business activities for which we have developed an intelligent dedicated network out of a security reason. Because if we use production network, there is a security concern. The office network does not have adequate bandwidth, right? Because for a station, every second there is a tens of thousands of data units for transmission. And we're able to analyze those data on the cloud. So these are 7 scenarios we have. This is overall architecture for intelligent metro, an intelligent metro station. In the process of our implementation, according to this unified structure and integrated infrastructure development and the united cloud and the big data, we built the testing center. We come up with the intelligent production zone. Network structure, we have 3 networks. Going forward, we will build the wired and the wireless intelligent dedicated networks. Otherwise, the current legacy networks do not suffice to support digital transformation. So on the lower panel of the slide, we have like the production backbone, we have the dedicated intelligent network, and also the office network. So data-driven, we try to achieve harmonization across disciplines. The intelligent applications are mainly deployed on a cloud platform with a centralized storage. We promote data fusion across multiple disciplines, and we do algorithmic modeling and simulation. And we unify the standards and a governance structure, and we have a fusion of the storage, and we enable sharing. We have an example on the bottom right corner of the slide. So some of the industry point of view, many IT companies, and also Huawei as well, it seems we're very interested in the big traffic at the metro station. This may be a myth because an operator, what is the situation that we're afraid of? It is usually the fault that may lead to big traffic with congestion, right? Because if the big traffic during rush hours in the morning and in the evening, right, if this regular type of a big traffic, which is not caused by fault, it is fine. If you look at those metro stations, there is no way for you to have accurate prediction and forecasting of the traffic. But in case of abnormality or a fault as a consequence, there is some big traffic, right? Now how can you dispose of those traffic? Say, if there is failure of the train cars, then we can leverage the expert analytics system for train cars. Then the information will be sent. Those data can be analyzed on the cloud, which will be transmitted to the operational command center, and then instructions will be issued, for example, to rescue a failure train or to evacuate some of the passengers. Then the station has also collected the data, knowing that the incoming train for which we need to evacuate passengers. All those data is realized and connected through the cloud. So the station receiving the data, then the metro station will start this contingency plan accordingly. Because in the past, there were layers of the communication of a message in the chain, but now with this kind of a system, it's very efficient. The contingency plan at the station or on the network level can be initiated right away. So we have already realized these ideas on many occasions. So 3 cases, they're available in the video. I'm going to skip the details in the interest of time. First, the integrated service featuring online and offline. The online service, it is based on the Metro on Your Palm app. The offline service, we have the unmanned scenarios. So now we're able to take the initiative to deliver services, and the passengers can enjoy those self-service. Second, the intelligent metro station, the kind of automatic operation 24/7, for example, starting from 4:30 in the early morning all the way till midnight, 24/7, and for each scenario that we cover, we try to develop those scenarios across the board. For instance, like the manual command transformed to digital intelligent command. But this is not our ultimate goal. Ultimately, we use computer to replace people for execution, but we're not there yet. Second, from a reactive disposal to proactive response. Third, we leverage those technical instruments for security. We have those electric escalator, right? If something wrong with the escalators, if we do not have manual people there on guard, then the passengers may be hurt or injured, right? If anything wrong with the escalators. If there is abnormality, we have a video-based analytics. In case the passengers may fall or get injured, then we can pick up this kind of a signal in the video surveillance. Then we can make arrangement right away to send over a team of those security guards or assistants. Third, intelligent O&M. And we have conservative metrics here in the slide. For each kilometer, how many people? After the launch of the smart station, we can reduce 2 to 3 heads per kilometer. Thus, it's very economically beneficial. So the intelligent metro station, the characteristics of the stations in Shenzhen. So first, the scope of the intelligent features has been expanded. First, we do not have a clear picture about the ultimate look of such a system, but now we have built in many intelligent features in the station. Second, the deep internet-based interconnectivity. Third, multi-domain coordination, like the broadband cluster, and also intelligent voice processing, Wi-Fi 6, cloud technology, big data, video algorithm, biometric recognition, so on and so forth. Number 5, we have done the verification. The overall architecture is able to be, let's say, rolled out in a broader scale. Finally, in conclusion, first, going forward, for sure, we're going to have the trend of a more migration from offline to online, and a transformation from a reactive to proactive. We're going to have those simplified design on the front end. As for requirements of our staff, it's going to be foolproof in terms of our staff kind of skill sets. In the future, fusion is going to be the key word with ICT, communication, storage, analytic, I&I, with those technological advancement, for sure, the kind of a professional fusion is going to be a must-have going forward. We have autonomous driving, and those drivers or pilots of the trains have been replaced, right, by autonomous driving system. And we also try to have a multi-system fusion, for example, signal system to be fused with a shielding door, right, and a signal to be fused with the train cars. What about our existing legacy? It is through cloud that we try to manage to break silos and to achieve a data fusion. So those are what we have already witnessed. In Shenzhen, there are silos across different professional domains. Number 3, digital transformation. This is quite a strong momentum. We talked about innovation-driven. We mentioned the concepts like requirements-driven, pinpoints-driven, so on and so forth. Because of those problems we face, we try to find a cure. But going forward, digital transformation for sure is going to be mainly vision-driven, right? It must be based on your vision. If we are only pinpoint-driven, there are always newer pinpoints, right? We have to think about the big picture in an integrated fashion, the vision about the future look of our company and operations, right? Only when we figure that out on the macro level, look at the big picture, could we pull off the digital transformation journey. Thank you. Thank you very much, Mr. Ho, for your wonderful remarks. So, Mr. Ho, from a young talent, now grown to a senior executive, very experienced in operations, deep insight into the huge implications of a digital on the rail transit system. Right now, over 300 kilometers of coverage, but by 2035, the total network is going to have a total mileage of coverage over 1,300 kilometers, right? So from this perspective, you're going to actually increasing your headcount, but in an efficient way, because you're going to leverage the digital tools to drive further the development of your operations. Because you used to be mainly dependent on people, but now you're mainly relying on digital with intelligence built in. So intelligent metro station, yeah, this is a very important touch point with the passengers. You have advanced experiences which definitely merit our attention.
然后我们希望
Mr. Ho talked about exploration this year. I'd like to invite you again to come back to us next year to talk about your success story and lessons learned. Next, we will have Mr. Jin Tao, Director of Technical Center of Shanghai Shentong Metro Group, to talk about their thoughts and experiences. Hello everyone, I will talk about our experience. I will talk more about the technical architecture. Because as the director of a technical center, I focus on that more naturally. We've seen a lot of business requirements and scenarios like Mr. Ho mentioned. I think that's not just smart station, but the larger concept of smart metro. But now from my perspective, I think more about when implementing digital transformation, what are in our control? What are the things that we are clear about and we can persist with? There are three parts in my presentation today, and because we are local enterprises, unlike the high-speed rail, which is managed centrally by the country. So first, let me talk about Shanghai Shentong Metro Group, but this won't be my focus. This company is called Shanghai Shentong Metro Group, founded in 2004. It is for investment, construction, operations, and development of Shanghai's urban rail transit. We have 17 lines, 416 stations. The +1 refers to the new one added this year. 705 kilometers of operating mileage. Due to the pandemic this year, we were hit. As you can see, last year, the daily passenger traffic was 10.63 million. So now we have this on the work days, because on the weekends, the passenger traffic was 60–70%. So last year, the heaviest was over 13 million. But now you see that before the Chinese New Year in 2020, it was merely over 12 million. So in the worst case, we have 400,000 passenger times, which made the metro lines even empty. So we've lost 1/3 of all passenger traffic, and we are coming to the end of 2020. So we were really affected by the pandemic. I went to other metro groups as well. So we have these super or ultra large cities like Beijing, Shanghai, Guangzhou, and Shenzhen. So for Tier 2 cities, smaller ones, they were also affected. So our lifestyle has changed. How the catering industry, entertainment are also changing. So I was talking to my family saying that how could people make a living if the economy continue to be that bad? Then in our industry, what can digital transformation do? We need to transform our business model so that we can better overcome future challenges. We need to improve our basic capabilities as well as innovation. Smart metro is the surface. The core is still digital transformation. So here's how we are doing. We have 3 domains. We have intelligent rolling stock O&M. The Internet of Trains started in 2011, and we have the train-to-ground wireless transmission. We have remote video systems started in 2017 so that we can have visibility over the rolling stocks. It's applied to Metro Line 3, 4, and 8. And then we have trackside vehicle detection. We can have visibility on the outer side of the train. It's used for line 17. So you see that these projects are not applied on the whole network, but just on some of the lines. And we have line 9 and 17 with the smart O&M for power supply. So that's the real situation. And then the communication and signaling smart O&M, we have 12, 13, and 16 with the UPC power supply and CBTC so that we can see their status online and we have real-time trouble locating. And also for the point machine, signaling is essential. And then for line 6, 7, 8, and 9, we had an accident a while ago, so we add some axle counters, and also we have temperature sensor for equipment rooms now. So you see that this is the situation that we have for some major projects. We have 6 smart stations. This is just one example, Xinjiang Wancheng Station. So I can't say clearly for now what it has done right, because I think we have achievements with different projects. We have 6 pilot stations, and each has its own features. But the one-click deployment Mr. Ho mentioned earlier is available. I think a major inspection noticed that one door failed to open, and that's why we now have the one-click opening. There's a common thing in different projects that we need a solid technical architecture to support all our explorations and pilots. So I've been talking to colleagues and others in the industry that who exactly are working on smart metro? Are we researching into smart metro, or are we just purchasing solutions provided by vendors? I think the key here is the improvement of the industry's capability. But of course, we need to decide the direction, and we need to make sure we are purchasing the right solution and product. I remember the 4 key roles here: our users, maintenance, and our vendors. They need to upgrade their production of, for example, the train carriages. And thirdly, IT companies. For example, Huawei. We believe that they are a very important supplier of the critical data foundation. And then some smart computing and processing capability vendors. They could be our partners. From the information center's perspective, we need to sort out what the technical architecture and systems are, because only having a high-level design is not enough. We need to make sure what we get and how we use them. So we have the cloud computing, edge devices integrated. So this is an overview of what we are working on. We have cloud, we have connectivity, but each function or each domain are working on their own way. Some use the internet, some use Wi-Fi, some use private line or dedicated wired network. This is the top-level design for Shanghai Shentong Metro. We have the device layer with a lot of sensors. In the middle, we have a cloud platform. On top, we have a data platform. Of course, there are middle platforms and data sharing. We have 3 smart fields: smart construction, smart O&M, operation and maintenance, and then smart services, including customer services. So here's the architecture. As we understand it, the key is the system, how to connect the cloud to the terminal devices. For the cloud, we are quite anxious recently because we've seen the progress in the metro industry. As applications are developed, we are the one who raise questions. For cloud, I think security is a critical question. For cloud security, it's not just isolation. In the past, we can isolate and disable some services to maintain security, but now it's not the same. We have physical isolated systems, but now we need to streamline the data for real-time status monitoring, and we need to collect data regarding quality and performance. We also need to share these capabilities and data to our apps on the internet. So we need to have isolation and streamlining at the same time. So how can we strike a balance? How do we decide on the trade-off? I think that's a question that we urgently need to answer. Now we have some special clouds, for example, for our ticketing system, but we may try to have one or more dedicated cloud for multiple lines. And eventually, the production, management, and other systems may be streamlined on one cloud. So, considering the cloud architecture, we have just decided on a security system. We have clear targets here and directions, but the technical details, I think, will be decided gradually with the isolation and streamlining of different clouds and functions. Now we have a lot of isolated points. We need to be clear what exactly is transmitted among them. The requirements on bandwidth, latency, bus, etc. We need to see how to isolate systems and enable interconnectivity, because interconnectivity must be restricted. We have proprietary protocol, industry proprietary protocol, and enterprise proprietary encryption. So we will need to see how it can be provisioned on security devices. And then network. I think this is by far the most mature solution we have now. We have a 3-layer. We have the core switches, 2 centers, and then the aggregation layer. We have an aggregation node for each line, and then the access nodes. For all the stations and management nodes, we have the access node. For the core, because we are covering a wide area, so for each line at the aggregation layer, we have a high-speed network. We use Huawei's solution there. And there are 2 peak areas. One is for production, the other for management information system. The production system emphasizes on OTN, the transmission. For management, we need to have more flexible networking, as well as flexible scalability. That's why we use MPLS VPN for the networking. As you can see here, we have the ATG capacity for the OTN, and we are able to expand it in the future. And thirdly, IoT. Now, different industries have different understanding of that. We focus a lot on the terminal devices, but how can these devices be connected to the digital platform? I don't think we have a unified idea among the industries, and it is not with top priority yet. But now we have different kinds of backhaul from the bus, from from their own sensors, from the public network. Some have access points for their sensors.
Once the data transmitted throughout the whole network for all your business activities, if you cannot manage the data with a platform in an integrated manner, then your business may crash. So from this perspective, it is necessary for us to integrate the terminal device into the IoT, right? It's not as simple as device on application directly. We need to come up with a interconnected platform for those different terminal devices. So before digital, it was physical system and a business system, right? Once we begin to build the digital world, then we have the sensors on the terminal side directly transferred to the application system. It is one of the options because the digital world is mapping on the physical world. There are two transmission options. First, the terminal directly reports to the physical system. Second option is to integrate the physical with the digital world with a digital twin, right? So we do development based on business object-oriented kind of a philosophy in order to make sure about business continuity. So right now, for this kind of a device side business, we need to rethink about it. If you look at the urban rail transit, I don't think there are companies that begin to consider comprehensive IoT. So I actually suggested to many other companies, like the train OEM manufacturers, they consider the possibilities of IoT, right? Because the applications are yearly available with one device, right? And devices transmitting data, but to where nobody has a clear idea. In the future, in sensing, those dedicated gateway and those networked gateway, those are some future directions to go. But we need to do more research and come up with more pilots. Going forward, we anticipate those wonderful solutions from the industry, so we can actually use those solutions down the road. We do not have an answer to these three questions yet, and we're still making exploratory efforts. We hope that through some of the key technologies, we can actually lay a solid basis for future digital transformation. So that's it for my presentation today. Thank you. Thank you very much, Mr. Jing, for your fantastic remarks. Shentong Metro talk about the perspective of ICT and talking about the layers of a digital metro, the key technologies, whilst Mr. Ho, the first speaker, talked about the business dimension. Then Huawei Technology Corporation Limited, as a pioneer as a digital technologies and one of the key vendors of such technologies, the perspectives are from Huawei. So the next speaker is Madam Huang Mingjie, Huawei Transportation Marketing and Solution Department, to deliver a presentation. Sorry, microphone please. Dear participants, good afternoon. My name is Huang Mingjie. I'm from Huawei Transportation Marketing and Solution Department. My title is actually the Urban Rail Digital Transformation Journey version 2.0. The year of 2018, there was the MPC 19th report stipulating the goal of China to develop itself into a powerhouse for transportation. In 2019, NDRC promulgated the guiding principle document mentioning efforts to be made to build like the transit and rail transit-based urban clusters. So the efficient interlinking across the cities within the urban cluster is going to be a very important driver for GDP growth. So here, the transit system is like artery for human body. It is a very important cornerstone. So how can we build those metropolitan cluster on top of a transit rail? So first, we need integrated infrastructure. So we have those different types of rail connections, right? between different regions and amongst different cities. So we enable integration and a fusion of those transit networks. And we connect the dots. So in Shenzhen Metro, they started earlier on. The Pingnan Rail, the Guangshen passenger line, and the Longhua, kind of a tram car, they have the integrated operation of those different lines. They offer very convenient passenger mobility service. So they are making efforts to create those great commuting circle within 1 hour of mobility. For example, at the Shibu station in Chengdu, there is great kind of a transfer system between Metro Line 2 and other metro service, and the switch between one line to another line on the same platform can be done very quickly and efficiently, thanks to the integrated infrastructure network, so that we can connect those various cities within the urban cluster, so that each city within a cluster in the metropolitan area can achieve co-development. So this is like a national strategy developing China into a powerhouse of a mobility, but we're subject to more stringent requirements. How can we build the smart urban rails? Vertically, we need to have the above-ground cities. Not only shall we pursue velocity and size, but also quality. We need to accelerate the digital transformation journey with more intelligence, so we can optimize the whole process featuring construction, operations, and businesses. Horizontally, various transportation signals, we need to connect those signals. So how can we transform from a single or siloed transport method to integrated transport development, and to connect those 4 types of networks? Under the new circumstances, we need to fuse the above-ground cities with the below-ground metros. The data flow and business sharing, these are linchpin to achieving the development of a smart urban rails. So based on those requirements, then we look at the business flow, and we try to look at the whole picture for the business flow. These are 2 business flows. First, passenger flow, like the passenger entering the station, passing the security check, then entering the platform, then exit from the gate. This is like the passenger information flow. Currently, the passenger information flow information is fragmented across various business systems. We need to pool those passenger information together so that they can buy the ticket based on voice interaction and facial recognition. The urban rail shall also enable information interaction and a connection with other services, so we can have a mutual recognition for a security check, and those basic data can be shared across the board. The next, as we know that one ID for travel, either in the format of a biometric recognition or QR code, we need one ID to recognize the passenger information. The next, another business flow for urban rail is the train operational flow, for example, covering the operations and also driving into the main line, so on and so forth. In the real world, there is a siloed business data. We need to build unified platform to congregate those data for assets in a business, so we can enable digitalized transfer and to achieve precise operations, so that we not only have a one ID for travel for passenger flow, but one map for operations for the train flow. We have passenger mobility data and production data. These types of data are highly interactive, and these are very important resources. We need to mine the data in a profound way to gain insight into the distinctive features of those data. So our goal is to enable the smart urban rail based on a digital platform. And with those rail property owners as well as the design institute experts, we have rounds and rounds of discussions. Then we have the overall technical structures with the several layers. network layer, platform layer, and a business layer. First, network layer. We leverage LT, dash N, 5G, Wi-Fi 6, so on and so forth. So we achieve the onboard wireless communication. And we also have the device side digitalization of the facilities. We are able to offer very secure big bandwidth. Now on the platform layer, we have the urban rail cloud as the bottom layer. We're able to achieve a resource sharing and on-demand allocation. On top of that, we also build in the AI, big data, and video capabilities. So we managed to create a shared and an open urban rail digital platform on the business layer, and we achieve digitalization of a business flow, helping those project owners to achieve a smart OEM, smart building, and intelligent operations, and facilitated mobility. Then the Urban Rail LLC, the center of a management and operation. This is like an integration center for data. So this is like the unified decision-making center and a joint command center. This is an integrated platform. So within the urban rail system, platform serves as a critical part. This slide shows you the evolutionary journey of the urban rail platform, prior to which there were stacks or siloed business systems that were rather fragmented, and there were information silos. In 2016, Huawei was the first to put forward the concept and solution of the urban rail platform, with which the business systems can enjoy those security, storage, resources, and on-demand allocation of resources is achieved. So this kind of a cloud platform can increase the utilization efficiency of resources by a factor of 5. So this 1.0 solution already deploys at Kunming Railway and other cities' railway as well, and some of the urban rail metro service already launched into operations based on the urban rail cloud. The new technologies are evolving, and we've built the digital platform on top of the urban rail cloud. Thus, the 2.0 era started. The digital platform, as we know that, it enables a data integration as well as a business harmonization, and it is able to meet in a better manner those business requirements. So on top of the cloud, there are 3 additional capabilities that are overlaid. First, there is new ICT capacity and offer a unified interface for business layer. Taking AI capacity as an example, there is AI computing power, AI model training platform. Therefore, it is easier to deploy new technologies, and an integrated platform is being built on a group level. So we get rid of those repetitive efforts on the part of each business department. So we can deploy those new technologies in a more efficient manner. Second, it is a data integration platform. It enables data connection, data cleansing, as well as some other functions. Then based on unified data standards and a unified data services, we're able to achieve real-time data sharing. So we turn data into assets. Then it is also a one-stop development platform with a graphic visual system. You can drag and then you can do assembly of those modules. So it enables innovative development. So all in all, this digital platform connected dots, those different business systems, the common features are extracted. As a result, we've managed to create a unified yet open platform. So this is a smart application based on the platform. And as we know, that we can break the overall platform into different pieces as well, because the business system is very broad in scope. So we need to actually gradually cascade the overall platform into different lower-level scenarios. So this solution gone through the verification. The Urban Rail IOC, smart construction, smart passenger transport, and a smart O&M. I'm going to walk you through each module later on.
First, we look at the smart construction solution, which is used mainly for construction projects. So we will need to manage the safety of the construction site. So safety, quality, and progress are most important. This is an example. For a certain city, there could be over 380 construction sites, but we only have a dozen of customers to inspect all the construction sites. So the workload could be extremely high and the efficiency is terribly low. So we can use an intelligent identification system to automatically using machine vision to analyze videos and images to automatically capture problems and send alarms. Real-time snapshots reduce violations by 30%. And also for track sites, we also have a smart scheduling because it's a very dangerous area. Vehicles could hit people or hit equipment, and speeding vehicles may overturn. So the intelligent warning can locate people and vehicles and equipment real-timely so that we can have a safe interval between manual or vehicle operations. Accidents are reduced by 85%. And also we have a 5G safety helmet. This helmet can help real-timely locate the operators and also obtain their body temperatures, heartbeat, pulse, and other data. When anomaly is detected, there could be an alarm so that we can better protect the on-site workers and reduce accidents. This is the solution for smart transport for passengers. So what we need to resolve is the problem of sudden heavy passenger traffic, and also we need to maintain the running distance of metro trains to improve customer experience and satisfaction. This smart solution collects multiple types of data. With AI algorithm, we can better predict heavy traffic real-timely, and so we can reduce the peak hour congestion by 10% and reduce the running distance of metro trains. With the passenger traffic prediction algorithm, we can also deduce the situation so that we can assist in decision-making and scheduling of the train operation, managing the passenger flow more efficiently. And then the smart O&M solution, Mr. Ho and Mr. Jin had already touched upon this. We focus on the train operation. When operating, the carriages may obtain a lot of data. So 25 GB of data could be generated with one run. So we use RFID 5G dump so that within 3 minutes we can transfer this data to our data center. The predictive algorithm can help predict the life of the service and assess its health, so that we transform from routine or fault-triggered repair to status-based and predictive repair. The proportion of people to vehicles is reduced from 0.6 to 0.48, and we saved 6 million Chinese yuan per line per year. Urban Rail IOC is a data integration platform. It enables status visibility so that we can have macro and micro views of data, follow the whole the end-to-end process of the train running. It's also an analysis and decision-making center. It analyzes the aggregated data and assists decision-making and supports other work of the group. It is also an emergency command center. It can display, warns, and predict emergency resources, risks, and incidents, and provides group-level emergency command and key event assurance. Its difference between IOC and NOCC is that IOC is at the group level, aggregating all kinds of operating and business data so that we can have network-wide intelligence. The construction of a smart urban rail is multifold. We need partners from different walks of life to engage. So partners like Huawei and others can help develop the applications, which is also an important contribution to the development of smart urban rail. So I've talked about the smart urban rail solution. And in Shenzhen, Wuhan, and Nanchang, use the Urban Rail Cloud 2.0 as pilot, and it worked out fine. So we are going to launch this solution on October 21st, 2020 at Metrotrans, and we sincerely invite you to the launch ceremony. That's all. Thank you. Thank you, Ms. Huang, for your excellent presentation. In the past 20 years, Huawei has served the transport industry, and we've witnessed actually every step of the development in urban rail. When we first started to have the responsibility division, we worked with the control and management of communication systems. And when you are facing the operational pressure from siloed systems, Huawei also tried our best to help you go through digital transformation. And at this phase, we are also engaging in the development of smart metro. I'd like to thank companies from Shanghai, Shenzhen, and other places. Thank you for your support for Huawei. And also, I'd like to thank you for attending this session today. We have small gifts for you at the door, but please scan the QR code when you grab your present. And I'd also like to thank our online audience watching this online session. It's unfortunate that you are not here in person, so you can't get the presents for yourself. Thank you very much, and I hope to see you next year.
There's a house we can build. Every room inside is filled with things from far away. The special things I compile, each one there to make you smile on a rainy day. They can say it all sounds crazy. They can say we've lost our minds. I don't care if they call us crazy. Run away to a world that we design. Every night I lie in bed, the brightest colors fill my head.